Hello everyone, welcome back to my channel. So I received a few emails and also in the comment section I saw to cover the whole syllabus for this SSB exam, but due to the time constraint it will not be possible because I have some time constraints, and the exam is also going to, I think it will be held in December or November last. So it will not be possible to cover the whole syllabus. So what we will do, we will solve the previous year's questions, and through these solutions I will be explaining all the necessary concepts. Okay, so watch the video carefully. So we'll start from 2018 questions. This is the first question in which a scalar function f is given, and we need to find out the line integral of grad of f dot dr, and this will be along the curve C, and this C is any curve from these 2 points. One is 1 2 2 to 3 4 0. Now our first job is to find out the grad of f, which will be minus x I cap minus y j cap minus z k cap divided by x square plus y square plus z square whole power 3 by 2. Okay. I expect all of you to calculate this grad of f by using the formula dou f by dou x I cap plus dou f by dou y j cap plus dou f by dou z k cap, right? So this will be the value of grad of f. Now what we need to do, we need to scale these parameters x, y, z into a single parameter, for example t. And how we can do it, we can write down the equation of straight line between these 2 points. It is x minus 1 divided by 3 minus 1 is equal to y minus 2 divided by 4 minus 2 is equal to z minus 2 divided by 0 minus 2 is equal to t. This will give x is equal to 2t plus 1, y is equal to 2t plus 2, and z is equal to 2 minus 2t. From this you can calculate the value of dx will be 2 dt, dy will be 2 dt, and dz will be minus 2 dt. Okay. Now what we need to do, now write down the value delta f dot dr, which will be negative outside, x dx plus y dy plus z dz divided by x square plus y square plus z square whole power 3 by 2. Now put all these values, because you have all these values x, y, z, dx, dy, dz, and it will be minus outside, x will be 2t plus 1 into dx will be 2 dt. So after all the calculations you will get 12t plus 2 divided by 12t square plus 4t plus 9 in the denominator, it is power 3 by 2 and dt. Now you can do this easily, and while doing so, you know that t value, this t value varies from 0 to 1, and how you can calculate it, you can just put x 1 and find out the value of t, and again you can put x is equal to 3, then you can find out the value of t. It will be from 0 to 1. Irrespective of what you are taking x value or y value or z value, you will get the same values of t that will be varying from 0 to 1. Right? So we will be integrating it over 0 to 1. Now you can see you can take this denominator term 12t square plus 4t plus 9 as s, and this will be ds is equal to 24t plus 4. Right? This implies we can write it down. This will be multiplied by dt, 12t plus 2 dt is equal to ds by 2. Now this you have obtained this numerator value, you can substitute. Now while doing this conversion, you can find the value of s, and s will be varying from 9 to 25. If you put the value of t0, then you will get 9, s is equal to 9. Then if you put t is equal to 1, then it will be 9 plus 4, that is 13, plus 12, that is 25, right? Now this is very easy. You can calculate this value, delta f dot dr is equal to minus 0 to 1. This is ds divided by 2 into 1 by s power 3 by 2. And after the calculation, you can find this will be from 9 to 25. My mistake. Yeah, 9 to 25. And after doing the calculation, you will find the value minus 2 by 15. This is the answer. So option B is correct. Right? Now let's go to the next question. So the next question is, if f is the conservative vector field, then curl of f will be pi or 2 pi or 4 pi or 0. You know, for a conservative field, you have, if this f is a vector field, then it will be 0 for conservative field, right? For conservative field. We will talk about this conservativeness in detail in the next slide. After a couple of questions, we will go in very detail, right? What are the conditions for conservativeness? We will talk about it. Now let's go to the third question. It is asking that calculate the divergence of f if f is minus x square I cap plus 2xy j cap. So f is given as minus x square I cap plus 2xy j cap. Now how can you find out the gradient, divergence? This will be delta fx by delta x plus delta fy by delta y. It will be minus 2x plus 2x. It will be 0. So option C is the correct one, and here option D is the correct one. Now the fourth question, now be careful for this fourth and fifth question. These two are very important questions. Fourth question, the question it is given that flux of f across a small circle C of a radius a. We have to find out this flux if divergence of f at the center of the circle is 3. So he is saying this divergence of f is equal to 3 at the center of the circle. Center of the circle. Now remember, the flux, if a vector field is given, then flux across the volume or flux across the surface is given by f dot ds. ds is the area element, and it is integrated over a surface S, right? And by using the Gauss divergence theorem, we can write it down as divergence of this vector field f dv over this volume integral, which is enclosing the surface S, right? Now the tricky part is here. We can take this term, this is the Gauss divergence theorem. We can put here flux is equal to delta dot f is 3, so 3 comes out. Now the volume integral of this volume which is enclosing the surface. Okay, so here remember, whenever we are applying the Gauss divergence theorem, then it should involve a volume which encloses this the required surface, right? So here a circle is given, right? Here is circle C is given. Now we cannot take the volume elements, or we can find out the volume integral of the circle. We must find a volume which encloses the circle. And which one is this? We can take a sphere. We can take a sphere which encloses the circle, and the sphere can be of radius a. then the volume of the sphere will be 4 by 3 pi a cube, and 3 gets cancelled, is equal to 4 pi a cube. Now see, in the option there is no volume term. This is in a square, this is in a, and this is in a square. Okay, so now what you can do, we can consider that there is no volume enclosing the circle, so we can take the answer as 0 because there is no other option. Either they have given grace mark in this question, or they are considering that there is no volume that encloses this circle, so the answer will be 0. Either to 1. Either grace mark was given or the answer is 0. Okay, I think this part is clear. Now let's go to the fifth question. If you see the second question, it is asking that if f is the conservative vector field, then what is the curl of f, and we have answered it that it is 0. Now he is giving that let f be defined on a simple connected region in space. If curl of f is equal to 0, then f is conservative, non-conservative, rotational, or irrotational. Now comes the tricky part. So whoever has answered this question 2 as 0 will straight away say this is conservative, right? But this is wrong. The answer is irrotational. Why? Now let's see the difference between irrotational and conservativeness. Here. So the condition of this irrotationality is curl of a vector field is 0 everywhere in the region of interest. Okay. So if I am taking f as a vector field, for the irrotationality condition, the curl of f must be 0. It signifies that this vector field f has no rotation. Okay, it has no rotation at any point inside the region. At any, this is any point inside the region, right? But for conservativeness, this f should be expressed as gradient of scalar function. Why? Because we know the curl of grad of a scalar function is always 0, right? You can write down here, curl of grad of phi is always 0. Okay, so if I'm taking a conservative vector field, then I'm taking curl of f is equal to 0. But remember, this f must be expressed in terms of minus grad of phi, minus grad of a scalar function phi. So these are the two conditions. First condition, this is for conservativeness. For conservativeness, first condition is the vector field must be expressed in terms of a scalar field, that is minus grad of scalar field. And second one is the curl of this vector field is 0. Now in the question C, it is given that curl of f is 0, but we cannot confirm that if this f can be expressed in terms of a scalar function or not. So we cannot assure that it expresses a conservative vector field. So the better or the more appropriate answer is irrotational. So f is irrotational, right? Okay. So now you must be wondering that what is the simply connected region, because in the question it has been written that f be defined on a simple connected region in space. Now what is simple connected region? So there are two conditions. First condition is a region is considered connected if any 2 points within the region can be joined by a continuous path. So both the points while okay, so let's take an example. I'm taking this surface, right? I'm taking one point here and one point here. If I So if I try to join these 2 points, then this line also remains within this region. It is not going out of the region, right? So this will be called, okay, this is the first condition. Now the second condition is, if I take any curve inside this region, then it must be shrinking within the region or without leaving the region. If I am taking this curve, let's say this is the simply connected region, I am taking this curve here. Now I shrink this region. I shrink this curve, and this remains within the region. It doesn't leave this region. So these are the examples of simply connected region. Simply connected region. Now let's take another example here, and it has hole inside it. This is hole, right? I'm taking one point here and another point here, right? Can I connect it without leaving the can I connect it without leaving the region? No, it passes through this hole. Okay, so this is not a connected region, right? So these are the 2 conditions. One is the 2 points within the region can be joined by continuous path that stays entirely within the region, and another one is it is also path connected, and every closed curve within the region can be continuously shrunk to a point without leaving the region, right? I think this part is also clear. Let's go to the next part. Okay. So the 6th question is, which of the following functions satisfy the functional equation f of x is equal to x for every real number? Now let's go option by option. So the first option is given as f of x is equal to 2x. Now if I take the function of a function of x, then it will be 2 into, we will place 2x in place of x. This will give 4x. This is not satisfying. Second option is f of x is equal to x square. Then function of x will be x square in place of x, then again square. This is x power 4. This is also not satisfying. The third part is f of x is equal to 2 minus x. Now function of x is equal to 2 minus, I will put 2 minus x in place of x. This will give 2 minus 2 plus x is equal to x. This is satisfying. And let's check the final option. F of x is equal to 2 root x. Then function of x will give 2 under root. We will take function of x in place of x, so it will be 2 under root x. It will give 2 root 2 x power 1 by 4. This is not as satisfying. So the answer, this option C, will be correct, right? Now let's go to the last question of this lecture. This is 7th question. Is asking the argument of z plus argument of z bar mod is equal to how much? We know z is equal to x plus iy and z bar is equal to x minus iy. So the argument of z will be tan inverse y by x, and argument of z bar mod will be tan inverse minus y by x. If we add these both, then tan inverse y by x plus tan inverse minus y by x is equal to, we can write down tan inverse minus y by x as tan inverse y by x as it is. This we can write down minus of tan inverse y by x. This is give 0, right? So for this lecture we will stop here, and in the next lecture we'll see a few more questions and explain all the concepts. Okay, if you have any doubt about anything, any part of this is lecture, then just mention in the comment section, or you can also mail me in my Gmail ID. I will give in the description. Okay, see you in the next lecture. Then don't forget to like and subscribe the channel. See you.